In this lesson, we are going to be talking about statistics, so let's get started. So you are going to find some math counts problems which deal with statistics. You're going to deal with mean, median, mode, and range. That's the basic things what you will get in math counts when it comes to statistics. Nothing too crazy, but let's just get started. So we're going to get started with mean. Now, mean is your average. So we can basically just call this the average. So this is used for like test scores, etc. to compute the average. We have two types of mean. We have arithmetic mean, we have geometric mean. I'm going to go over arithmetic and geometric mean. Arithmetic mean is simple. Let's say we have 2 and 3, and we want to find the mean of 2 and 3. To compute the arithmetic mean of a set of n numbers, you just sum the numbers up and divide by the number of numbers. So here we have two values. Divide by 2. 2 plus 3 is 5. We get 5 over 2 as our arithmetic mean. So, essentially, if you have a set of, let's say we have two numbers, n and k, and this just keeps repeating, or we have a lot more sets of numbers, and let's say we have f numbers. So what we want to do is we're dividing by f, and then we sum. Let's say we have the sum of our values is, let's say, s. So we do s divided by f to get the arithmetic mean. Now, the geometric mean is a little bit different. Let's compute the geometric mean of 2 and 3. The geometric mean of 2 and 3 can easily be computed. We just take the nth root of the product. Here we have two elements, or two values. We have 2 and 3. There are two of them, so n is equal to 2. And then we take the product, 2 times 3, which is 6. And we have the square root of 6 as our geometric mean. And we don't need this 2 up top. This is just a square root of 6. And that's how that can be simplified. So whenever you have the geometric mean, let's say we have n, k, a, b. The way we're going to compute the geometric mean is by taking the nth root of the amount of numbers. We have 1, 2, 3, 4 numbers, so n is equal to 4. And then we take the product in the body, so n, k, a, b is going to be our geometric mean of n, k, a, and b. We have 4 values. We take the 4th root of n, the product, n, k, a, b. All of these are getting multiplied. And that's how you compute the geometric mean. Now let's move on to median. Median is the middle number. Middle value. So if we have like 2, 3, 4, 5, 1, 6. To find the median, we first need to arrange it from least to greatest. And find the value such that we have equal number of numbers on both sides. So here we see we have 2 of these numbers. We have 3 and 4. Now, whenever we have two numbers, the median, we take their average. Now, we take the arithmetic mean of the two numbers in the middle. So here we have 3 and 4. We take the arithmetic mean of 3 and 4. 3 plus 4 is 7. Two values, divide by 2. Our median is 7 over 2. So our median is simply 7 over 2. Now, if we have something a little bit simpler, we have 2, 3, 1, 4, 5. Arrange from least to greatest. And find the middle value. Here we have 3 equal number of values on both sides, so the median of this list is just 3. So that's the median. Now on the same page, on the same slide, we know what median is. We're going to find what mode is. Now the mode is not really, it doesn't appear too much in MathCounts, but when it does, it's important that you know what the mode is. Let's say we have 1, 2, 2, 3, 5, and we have 4, 4. And we want to find the mode of this set of values. Now to find the mode, we find the value that occurs the most times. So let's see, we have 2. Let's just place in our values. For 2, we have 1, 2. 2 occurs 2 times. 1 occurs once. What do I see that might be the mode? I see 4 might be the mode. 4 occurs 1, 2, 3, 4 times. 3, no. So no other value repeats more than 4, so the mode is 4, and that's how you would find the mode. There's no such quick trick to do it. But yeah, that's how you would find the mode. Now, let's move on to range. Again, you won't really find range too much in MathCounts problems, but range is the max minus the min. So if we have 1, 5, 9, 2, 7, 6, 3, the range is the largest value, 9, minus the smallest value, 1. So the range of this is 8. The range of these set of values is 8. That's all you gotta know for statistics and MathCounts. Mean, median, mode, and range. Mean, you gotta know arithmetic and geometric mean. Range, you have to know, you have to know range. You have to know median and mode. Now, geometric mean doesn't come too much in MathCounts problems, but when it does, it's important that you know what geometric mean is as well. So keep geometric mean as something also that's important in MathCounts. Now, let's move on to the problems. In Mrs. Marsh's algebra class, 30 of the 6 students took the Chapter 4 test, and the mean score was 72%. Notice how 30 students took the algebra test. The next day, the other 6 students took the test, and their mean score was 78%. What does the new class mean? Express your answer as a percent. The problem credits go to the MathCounts Foundation for the school sprint round. Now, let's have the first, we have 30 students, and the mean, we're going to compute the arithmetic mean. Now, 30 to 36 students took the Chapter 4 test, and the class mean was 72%. Now, we could just create 30 variables and do A plus B plus C plus D plus E plus F all the way until we reach the 30th. Well, the alphabet only has 26 letters, so we'd have to, so basically we can't just make 30 variables. 1, that's not even possible. 2, we don't need to. Think of what we do in mean. When we find the mean, we're finding the average, right? And we sum the number of values. We're finding the arithmetic mean, we sum the number of values. So essentially, all we care about is the sum, and we only need one variable. Let's put all the sum of the 30 students' test scores in a variable x. and their mean was 72%. So their mean score was 72%. Now all we need to do is solve for x. X is equal to 72 multiplied by 30. Let's compute that. 72 multiplied by 30, we have 2 times 0 is 0, 0 over here, 2 times 3 is 6, 7 times 3 is 21. Alright, so we know that 2,160 is the sum of the scores of the 30 students. The next day, the other 6 students took the test, and their mean score was 78%. Let's let their sum be y, and their mean was 78%. Y is equal to 78 multiplied by 6. We can just compute that by hand. 8 times 6 is 48. 7 times 6 is 42. 42 plus 4, that's 46. 468 is y. And we have everything we really need. We don't need these computations anymore. We have our x and y values. Now, what's the problem asking us? The problem is asking us, what is the new mean score after these guys took the test? Now, the sum of their scores is 468. The sum of these guys' scores is 2,160. We're asking for the class mean. Now, there's 36 students in the class, so we're going to be dividing the sum by 36, and notice that x plus y represents the entire class, the sum of their scores. This covers 30 students, and this covers 6 students. So all we need to do is do 2,160 plus 468. And once we compute this, we'll find the new mean score. Now we have 2,160 plus 468. We can just compute that. 0 plus 8, that's 8. 6 plus 6 is 12. 4, 5, 6, we have 2,628, 2,628, all divided by 36. All we need to do is compute 2,628 divided by 36, and we'll have our answer. So try to see if you can finish out the problem from here. Alright, let's divide it out. 36 times 7 is 252. We're left with 10. Now we have 108 divided by 36. We see that if we multiply by 3, we're going to have 8 over here. So let's try multiplying by 3. We just test 3. 6 times 3 is 18. 3 times 3 is 9. Plus 1 is 10. 10. So we have 73. So this equals 73. And we see that our computation is equal to 73. Now, express your answer as a percent. This means that the mean score for the entire class is 73%. And we're done with this problem. Let's move on to the next problem. The mean of a set of integers is -1. The sum of the integers is -4. How many integers are in the set? Notice that the mean is -1. This means that the sum and the number of numbers build a quotient of -1. Let's test the simplest case possible. The sum of the integers is -1. So we can have -1, -1, -1, and -1. When we sum these, we get -4. So the mean is also -1. Now we notice if we're going to build this mean of -1, both this over the top part needs to be equal to -4, and we need to have four values which sum in -4, and then that has to be 4 values, so we divide by 4 to get the mean. So this means that there has to be 4 integers in the set such that the mean is -1 and the sum of the integers is -4. So that's the basic statistics and math counts. Hopefully this video is helpful, and yeah.